Most planes are long metal tubes filled with really long cables. These cables carry data, radio signals and power. Well, what happens when one of these cables breaks, is mismatched, and there's no visible signs of damage? How would you find a fault on an aircraft like this, an over 60-metre Concorde? Or the Comet 4? Or the York? Or even an ex-Royal aircraft such as the BAe 146. Well, today we're going to show you an incredibly accurate way to measure a break along a huge cable. And also, I'm in the Queen's chair. We are here at the Duxford Imperial War Museum, and thanks to the Duxford Aviation Society, we're able to perform a time-domain reflector test on their very own ex-Royal airliner, the BAe 146. Now let's hear a bit about the BAe 146 from Dave.
Okay, so the 146 was originally designed in the early 80s, but probably late 70s, early 80s. So they built 387, which well outweighs any of the other airliners that we have ever built in this country. This particular aeroplane was built specifically for the Royal Air Force. It was fitted out as a VIP aeroplane and was named a Statesman. It then went into service with the Royal Flight, and during its service up until 2022, it carried all members of the royal family, numerous dignitaries, prime ministers, all over the world. So it's a very well-travelled aeroplane. It arrived January 22. It sat around for quite a while before we had all the spares arrived from, they had to come up from Australia in actual fact. The Timex engines and wheels and brakes and all the bits that we needed to keep her looking okay. Then we finally brought her down here to a parked position now.
Before we jump into time-domain reflector test, what exactly is it and what does it show? A TDR is a test that uses the sharp pulse of energy down a conductor and measures the reflected energy from any anomalies throughout the cable. This can be used to detect breaks, shorts and changes in cable impedance, which is important when it comes to radio frequency antennas in high-speed design. This process is scalable and incredibly versatile. More commonly, you'll see a TDR being used on a mobile phone and PCBs within the mobile phone to test the high-frequency traces. You can use this to test for disconnections in high-frequency Ethernet cables or even mains cables throughout your house, or even to test the integrity or moisture of setting concrete like this very taxiway. But can you not do the same test with a multimeter? Imagine doing a continuity test down a 62-metre aircraft where you would need to probe at both ends. Impossible. Doing a TDR test is single-ended, meaning you only need to test from one end of the conductor. Also, a TDR test will tell you exactly how far down the conductor a break may be, along with any impedance changes throughout the length of the cable. So let's rewind back to the year 1988. The 146 has done its pre-flight checks to take the Queen and Prince Philip to the Netherlands to see Queen Beatrix. But we're having a communication issue. In this made-up scenario, one of the pre-flight checks has come up with a fault between the radio and a VHF antenna. So let's see if we can figure out what it is. The fault seems to be an issue with a shielded cable somewhere across the entire length of the aircraft, and it would be almost impossible to diagnose without removing panels and stripping out the system. This is where a TDR test comes in, using our high-speed USB sampling oscilloscope. Once it's interfaced into the aircraft coax cable, the PicoScope sends a high-speed pulse down the cable and records the pulse reflection. Today, Stuart is using the PicoScope 9300 sampling oscilloscope. This instrument can send high-speed pulses through the match splitter, and using the PicoSample software, a user can read and measure the reflected signal. Depending on what the cable fault may be, it will be shown as a different shape reflection that can be categorized into one of the 4 steps. A straight line shows the exact same impedance all the way through the cable. A small step up or down shows a changing impedance. A step down to 0 shows a short to ground somewhere along the line. And a step to infinite impedance means a break in the cable. Stuart is setting up the PicoScope to measure the ultra high frequency antenna cable to test for one of these scenarios.
Today, me and my colleagues are looking at characterising a VHF communication system, which in this example is on a BAe 146 aircraft. And what I'm doing is using the PicoScope 9311 to characterise from the antenna feed at the back of the transceiver mount, the back plane, and what we're going to do is measure the characteristic impedance from below the flight deck all the way to VHF COM1 blade antenna. So I've now been in the avionics bay, connected our 9311 TDR capability, which is both single-ended and differential. In this example, we're using a single-ended because we're characterised the antenna and the antenna cable and the antenna feed. And as you can see, we're using our software PicoSample 3 with its TDR capability to ensure that our impedances are fully matched. And the results are actually fairly good, showing that the installation in this VHF COM system is very well matched to the antenna. So what we have here is our PicoScope 9311, which purely does distance to measurement results. So in other words, we can stimulate our device under test, or in this case a coax cable, in the environment and look for its characteristic impedance. Now with a VNA we can do this, but what we'd have to do is then take the frequency domain, the S parameter data, and do an inverse FFT to get us time domain data. Well, as you can see from the screen, you'll notice that the line there is pretty well flat and matched. So going from the antenna feed all the way to the antenna, you'll see there's a slight drop of impedance of approximately 2 ohms, showing that you know, going to its match load, it's pretty on point. So what we'd expect to see is a nice matched impedance line, and we can clearly see we have that here. So in this example, what we're doing is we're getting reliability. Not only can we get an impedance measurement, we can get a distance to measurement. In other words, we can look along the cable and spot spot any impurities or in differences in impedances in terms of spec to about 4 millimeters.
And that's how you can test for impedance changes and cable breaks along cables hundreds of meters long. Remember, you can use a TDR for a wide variety of testing applications, from large cable runs like this aircraft, or small PCB impedance changes in a single-ended material testing. Let's hear what the importance of aircraft wiring is from the Duxford Aviation Society's engineer, David.
Well, quite obviously no difference to in your house. If you switch something on, you want it to work. So, yeah, it's. I mean, historically, some of the aircraft that even sat out there on the flight line right as a result, the only electrics that would have been on it was the ignition system. They wouldn't have had anything else. That would have been it. If they want to communicate with the ground, they'd wave or flash a torch. That was it. But as we've come up through the years, radios, and managed to get a radio in an aeroplane, so we need to generators on the engines and batteries and blah blah blah. It just goes on and on. So you've got to connect it all together, so the wiring there, and it moves on. I mean, through historically, obviously, electronics get smaller, you can get more and more in, so you get more and more wiring, and then we went into the ARINC 429, I think Boeing 757 was one of the first aeroplanes to use ARINC 429 system, where you're using one cable to do more than one job. It's all new, and then we're into fly-by-light now, where it's optical cables rather than electrical cables. So historically we come down, and now we're at the point with the 787. That aeroplane sits on the ramp, and if something goes wrong, I mean, it actually sends you a message in the crew room to say there's something wrong with me, come out and fix me. They're insane aeroplanes. They're just the technology's gone so far now. It's
And a lot of automation as well.
And so from an engineer's point of view, obviously back not that long ago, 50 years ago, 60 years ago, you have to forget 50 years isn't that far away. 60 years ago, would have been a guy with a battery and a lamp, and oh no, lost continuity there, and have to go and find the brake. Then an aeroplane of this age, the 146, would have had a lot of built-in test equipment. So you'd go to the box, press the button, and it would tell you whether there was a break in the wire or something in the box was broken by a series of lights or whatever. Bit further along, the A320, they've got the screens on here which you can use and interrogate every box on the aeroplane. Just go into the menus and look at them. So you haven't even got to go out the flight deck. I was saying to the 787 where you don't even have to do that. The aeroplane tells you, sends you a text message. So it's moved along a hell of a lot. But conversely, the 787 is a virtually all electric aeroplane. Apart from some very small parts, they've taken all the hydraulics out of it as well. So it's
all motors.
Yeah, not motors, but yeah, motors. Even the brakes are electric; they're not hydraulic. You know, it's just. But then they've got these massive generators on the engines as well. So, yeah. On an air show days and other days during the year, she's open to the public. We make a small fee, charge a small fee for you to walk through it with a guided tour, well-versed guide who'll give you all the little stories about where the Queen sat and show you all the different parts sit through the aeroplane. So Duxford Aviation Society was formed in 1975. A bunch of aviation enthusiasts that were, I'm going to say we because I was involved. We were coming to the airfield and basically looking after the aircraft that the Imperial War Museum had stored here. It was just a store, it wasn't a museum as such. And we'd had several aircraft and basically just put them together and kept them clean and looked after them. And the society since then has grown and grown and grown. We've through donations got this wonderful collection of airliners. It's operated as the British Airliner Collection. The society's grown. We've got only in excess of 2,000 members now, I believe. It's all volunteers. Any money we make from air shows and whatever, it all just goes straight back in, and we just use it. So we're painting the VC10, which you can imagine it's a lot of paint. A lot of paint, and we've got members who everything from retired engineers. Some are aircraft engineers, many are not. Doctors, teachers. They're just enthusiasts. Come, put a pair of overalls on, clean, polish, cut bits of metal up, whatever they need to be done, and everybody has good fun basically. We work in complete partnership with Imperial War Museum, always have done, and we take a big part in running the air shows. We always supply staff for the flight line and manning the security gates on the flight line and things like that. So.
If you're interested in the PicoScope 9000 series used today in this video, we provide demos and technical support from the link in the description. Thank you again to the Duxford Aviation Society for letting us perform a TDR test on here. And remember, if you want to see any of these aircraft, they're at the Duxford Imperial War Museum, and grab your tickets in the description below.